The first one is a multiple choice question related to the percentage uncertainty. So in an experiment to determine the Young's modulus of a material, the measurements taken as shown, the mass hung on the end, that's shown to us, original length, diameter, and the extension is also shown. The Young's modulus is calculated by this formula, where g is the expression of a free fall acceleration due to gravity. The calculated value of the Young's modulus 1.6 into 10 power 10 Newton per meter square. How should the calculated value of E and its uncertainties expressed? So first, what we do, because we have the formula that E is equals to 4 mg L pi d square E. So there is no uncertainty in the 4. 4 is a number, a constant, so there is no uncertainty. The pi is also a number, like a constant value is there. When you have a constant value, does not have any uncertainty. Is it audible? My sound is clear to everyone? So 4, okay. So we have 4 pi mgl. So there's an uncertainty in m. There's an uncertainty, and g is also a constant, so it does not have any uncertainty. A fixed value, there's an uncertainty in d, and there's an uncertainty in e. So because when quantities are multiplied or divided, instead of adding the uncertainties, we add the percentage uncertainties. So what we do, we'll find the percentage uncertainty in the m. What about the percentage uncertainty in m? The value of the m is 0.002. That is the uncertainty divided by the value recorded, which is 2.3 into 100. That will give us the percentage uncertainty in m. Same way, we'll find the percentage uncertainty in L. So how to get the percentage uncertainty in L? The uncertainty, the absolute uncertainty, which is 0.005 divided by the measured value 2.864 times 100. That will give us the percentage uncertainty in L. Then we have a D square in the formula. So we need the percentage uncertainty in D square. So what is the percentage uncertainty in D square? The uncertainty in D is 0.01. The value which we recorded, that is 0.82. But because it's a D square, this is the uncertainty in D. So if in D square, it should be twice. If it was D cube, it will be thrice. If it D power 4, it will be quadruple, like multiply by 4. And then into 100. So what power is here? That is multiplied. So we got the percentage uncertainty in D. And how to get the percentage uncertainty in E? So to know the percentage uncertainty in E, the uncertainty, the absolute uncertainty divided by the value recorded into 100, that will give us the percentage uncertainty in E. And then what is the total percentage uncertainty in the Young's modulus? The total percentage uncertainty in the Young's modulus is a percentage uncertainty in M plus the percentage uncertainty in L plus the percentage uncertainty in D square plus the percentage uncertainty in E. Because uncertainty always add up. If the quantities have different units or multiplied or divided, then we add the percentage uncertainties rather than directly adding the uncertainty. So this will give us the total percentage uncertainty in E, and this total percentage uncertainty in E will take out what is the fraction in terms of this. No, because it is a percentage uncertainty, so unit conversion is not at all important. Because if you convert the unit and take the percentage, or you don't convert the unit and take percentage, it will give the same result. That's why when we measure a percentage uncertainty, unit conversion is not at all important. So what we do, we got the percentage uncertainty in M, percentage uncertainty in L, percentage uncertainty in D square, and percentage uncertainty in extension. And we'll get the total percentage uncertainty in the Young's modulus. And then we'll find what fraction or of this total value this refers to. And then that will be the right answer. So The idea is that whenever we have a percentage uncertainty, unit conversion, even one unit is in centimeter, another one millimeter, another one in meter, but no need to convert the unit because the percentage uncertainty does not depends on the unit. So you have to individually work out the percentage uncertainty in each quantity and then sum up to get the total. The next question. A beam is vertically polarized monochromatic light. So we have a vertically polarized monochromatic light. And this is a direction of the transmission axis. So as you can see, they are parallel to each other. Maximum amount of a light will pass through. Now, the transmission axis of the filter is initially vertical and the transmitted light beam has the same intensity as the incident. We know the relation between, like, if this is an incident light and this is a transmitted light. So what is the formula which relate the incident and the transmitted light? The transmitted light intensity will be equals to I naught cosine theta whole square. This is a formula which relate. And what is the value of the theta here? Because if they are both parallel, so theta is equals to 0. And what is cosine 0? Cosine 0 is equals to 1. So means this whole factor will be equals to 1. So I is equals to I naught 1 square, or we can also say I is equals to I naught. So when the plane of the polarizing filter and the light which incident, if they are parallel to each other, in that case, the maximum amount of the light will pass through. But now the filter may be rotated about a direction to change the angle. State one angle of a transmission axis to the vertical. There is no transmitted light, like it will completely block the light. So if the plane is parallel to the incident light, maximum amount will pass through. But what will happen if we make it perpendicular or a 90-degree? So if the plane is 90-degree or perpendicular, what will happen to our transmitted light? There will be no transmission, because when the plane of the polarizing filter is parallel to the polarized light, plane of the polarized light, maximum light will pass through. But when the plane of the polarizing filter are perpendicular to the incident light, then there will be no light able to pass through. So what should be the angle between them? The light which is incident and the plane of the polarizing filter. So this angle should be 90-degree. And we know if theta is equals to 90, what is cosine 90? Cosine 90 is equals to 0. So means this whole factor which we have I equals I naught cosine 90 whole square. Cosine 90 is 0. So if anything is multiplied by 0, so that will get a 0 as a result. That's why there will be no light, which is when the planes are perpendicular to each other, or angle between the incident light and the polarizing filter is 90-degree, or they're perpendicular to each other. If there was an unpolarized light, like light which is having multiple component, and that is incident, so in that case, what will happen? It will turn into a polarized light, and only component which is parallel to the polarizing filter is able to pass through. If I have a light which is having only one component, and that is perpendicular to the plane of polarizing filter, in that case, we don't have any light pass through. The next is the filter is now positioned with the transmission axis theta, as shown in the figure 5.2. The intensity of the transmitted light and the intensity of the incident light, the ratio is 0.75. So the incident light is called I naught, and the transmitted light intensity is I. So in the question, they mention us that the ratio between them, the ratio between I, the intensity of the transmitted light divided by intensity of the incident light, this ratio is equals to 0.75 between them. Now the question is, calculate the angle. So if we need an angle, so this ratio is equals to 0.75, and we know this formula that I is equals to the light which transmitted is equals to intensity of the incident light cosine theta whole square. If I further simplify, I naught is multiplied, other side it will be divided. So it will be I over I naught is equals to cosine theta whole square. Now, the I over I naught is given in the previous page that it is equals to 0.75. So this ratio between I over I naught is 0.75. So I can say the 0.75 is equals to cosine theta whole square. Then I need theta. So I have to simplify first. It's a whole square, so I will take root both sides. So square will cancel with root. So we'll have under root 0.75. So root of a 0.75, and then so root of 0.75 is equivalent to 0.75, root is equivalent to 0.86. So this is equals to 0.866. So 0.866 is equals to cosine theta. But I need theta, so the cosine will move other side. So this will become cosine inverse 0.866, that is equals to theta. So when we work out the value for theta or angle, that is 30 degrees. Degrees already written, so I just have to write 30. That's how we solve the angle, like at what angle the transmitted light and the incident light ratio will be 0.75. The next is the amplitude of the intensity, transmitted light over amplitude of the incident light. So we know that amplitude, the relation between the intensity and amplitude, then intensity is directly proportional to amplitude square. Like if amplitude is double, intensity will be 4 times. If amplitude is 3 times, intensity will be 9 times. So, or we can also say, because when two quantities are directly proportional, the ratio is constant, or I can say that intensity is equals to K times amplitude square. Or I can also say the ratio between the intensity and the amplitude square must be constant. Like that constant we call K. So you can write the equation like this, or you can also write the equation other way around. No difference. This is for the light which is transmitted. Same way for incident light, the intensity of the incident light will be equals to K times the amplitude square of the incident light. So we have the two equations which relate the amplitude and the intensity. In the question, we need a ratio between them. We need the ratio of amplitude of the transmitted light and the amplitude of the incident light. So if we divide these two equations, I can say I is equals to K times A square divided by I naught K times A naught square. The K is the common, so that will cancel out. What is I over I naught? That is given in the beginning of the question, the ratio was 0.75. So 0.75 is equals to amplitudes like of the transmitted light square divided by amplitude of the incident. Because they both have a square, so I can write as a common square. So I can put this in a bracket and put square hole. Now we need only the ratio between them, not their square. So I will just take a root both side. So when we take a root both side, this square will cancel with the root and we'll get root 0.75. Yes, you can make a subject. That can also be done. You will get the same result. Like if you make K as a subject for both and then solve compare the two equations, same result you will get. So the ratio will be equals to 0.866. And the ratio does not have any unit. No unit is there because it's a simplest ratio between the two quantities. Ratios cannot have units. In this question, a beam of a laser now is passing through a diffraction grating. Look, when you see a question related to a diffraction grating, just recall the idea that for a diffraction grating, the formula is d sine theta is equals to n lambda. That's a formula. If it was a double slit experiment, lambda is equals to ax over d, if there was a double slit. But this is a grating element, it's already mentioned, so I should use a formula d sine theta equals to n lambda. There are 2,400 lines are there per millimeter. Like 1 millimeter is having this many lines. The detector sensitive to the waves that are emitted move through at an angle of 180. In order to detect the maximas produced, the wave passing through the grating element, calculate the number of the maximas detected as a detector move 180 degree. Like if the detector was originally at this point, or the detector was originally at this point, and it moves, how many maximas it will record? That is the question. So this is a common question. Even in Edexcel also, this was a last year question. The same question was there. How many maximas could be recorded? So first, what we do, we don't take this theta is what this theta is always angle from a central maxima. So at the center, we will always have a maxima which we call central maxima, and this theta is always the angle between the central maxima and the maxima. So what could be the maximum angle we can have? The maximum angle what we can have 90 degrees. Because so the maximum value of the theta could be 90, not 180. Why? Because this theta is always the angle taken from the central maxima. So from central maxima to this position, this angle could be 90 maximum. So the theta we got, according to this question, the theta we got 90. How to get the value for D? D is the total length divided by number of the lines. So what is the total length? It is per millimeter or 1 millimeter. So 1 millimeter is equals to 0.001 meter. So it will be 0.001 meter. The length, because the D is the total length divided by number of the lines. So D is equals to 0.001 divided by 2400. That will give us the value for D. What about the wavelength? So D is coming out 4.16 into 10 to the power minus 7. Okay. Where n is the order of the image, like we are finding what is the order, and wavelength will be given in the question. Yeah, for exponent is 4.17, exponent minus 7 is there. Exponent should be there because it's 0.001 divided by 240. So definitely there will be an exponent. Now the wavelength, because the student have just sent this question, not the previous part, but they will provide us a wavelength as well. So I'm just taking a random number here right now. For a wavelength, as it will be there in the exam. So let's say the wavelength we are taking, it's a laser light 600 nanometer. So 600 into 10 to the power minus 9 meter. So how to solve this question? So we have the formula that d sine theta is equals to n lambda, where d was 4.17 into 10 to the power minus 7. Sine theta, what is our theta? It is 90 because sine 90 maximum is there. N is the order of the image and lambda is the wavelength. So 600 into 10 to the power minus 9. We'll simplify. So 4.17 exponent minus 7. This sine 90 will be 1 divided by 600 into 10 to the power minus 9. What's the answer for n? What's the value for n when you divide? 4.17 exponent minus 7 divided by, or let's change the value for wavelength. Let's take as minus 7 only. Or this is 4.17 exponent, just a minute. 4.17 exponent negative d. Let me just confirm the value for d. 0.001 divided by 2400. Okay. So we have 4.17 exponent minus 7 divided by 600 nanometer. Divided by what is the wavelength given in the question? Yes, so the student who sent this question, can you tell the wavelength? Exact wavelength, so we'll do a calculation from that value only. Because the n will come out different for different wavelengths. So let's take 6,000 exponent minus 3. So 4.17 exponent minus 7 divided by 6,000 exponent minus 9. Or yes, I think Shahid, you have sent this question. What is the wavelength in the previous part? To get the exact number. Wavelength, because we need the actual wavelength for this laser light. Or if we know the answer, can we find the wavelength? No, because the question is what we need the number of the maximas. Like how many maximas are there? Like first maxima n is equals to 1, then second maxima n is equals to 2. So the value of the wavelength is important here. Because from that wavelength, we can conclude that how many maximas are there in this region. That's why I need the exact number of wavelength. Or I can take a number 660 nanometer. Okay. 660 nanometer. So this was 660 into 10 to the power minus 9. So 660 into 10 to the power minus 9. What's the answer now? For value of n? 0.63. 0.63 does not make sense because it should be a number, like certain maxima should be there. Beam of a light passes. Yeah, that is 0. That's I'm saying it does not make sense. This is n is equals to 0, then n is equal, there should be specific number d. We have d sine theta is equals to n lambda. This we are taking as 90. So sine 90 is equals to 1. The theta is equals to 90. This whole factor will be 1. So d is equals to n lambda. So d over lambda is equals to n. To get the value of a d, The diffraction grating has 2400 lines per millimeter. 1 millimeter is how many meters? 0.001 divided by 2400. So 0.001 divided by 2400. That will give us 1, 2, 3, 4, 5, 6, 7. It's giving the same 4.16 into 10 power minus 7 meter lines per millimeter. Like it, this is this many line, the length of the line, because the total length divided by the number of the lines, and D is 660 nanometers, so 616 to 10 power minus 9. It's giving the same answer. So 0.63 n is equal. But how to get the number of maxima? The number of the maxima, like how many maximas are here on this side, and how the total maximas for a 180-degree angle, it is always 2n plus 1. Why it is 2n plus 1? Because like you will have maximas on this side, you will have maximas on this side, and then plus, like this is to get the total number of the maximas. Like you will have the maxima, like n is a number of the maximas. So we'll have maximas on this side, and we'll have maxima on this side, and we'll have a central maxima. So the total number of the maximas will be equals to 2n plus 1. So 2 into 0.63 plus 1. What's the final answer? So 2 into 0.63 plus 1. So it is about 2.26 maximas are there for an angle of 180 degree. But I think it should be around, usually it's about around 5. So the number of the maxima, how to know the number of maxima? Like here, we call the number of the maximas are n. And here also, like let's say, here also the number of the maximas are n. So what is the total number of the maximas? 2n. Plus there is always a central maxima. So the total number of the maximas for an angle change of a 180 degree is always 2n plus 1. Number of the maximas in the 90 for an angle of a 90 degrees from the central maxima till this position, this will always be equals to n. And the number of the maximas in this one is also n. But what is the total number of the maximas? So it will be equals to 2n plus 1. Why 2n plus 1? Because n maximas here, and always there is a central maxima. So that's why the total number of the maximas for an angle of 180 degrees will be equals to 2n plus 1. Is it clear, this one? So if the half of the question is given to you, like only this part is given and they ask the number of the maximas, so then you will get by n. But if they ask for 180, it's always 2n plus 1. Two cars, A and B, are racing along a track. The car A is moving at a constant speed of 93. So this car is moving at a speed of 93 meters per second. At a particular instant, the car B is 9 meters ahead. So car A, 9 meters ahead of a car B. At this instant, the car B has a velocity of 93. So at this point, the car B is also having a velocity of 93 and it is accelerating. It has a constant acceleration of 14. So this car is accelerating, car B, and the car A is not accelerating. Show that the car A and B are side after 1.1 second. Like if they are side by side, it means the distance covered by car A will be equals to distance covered by car B. So the distance, because the car A is moving at a constant speed, when anything move at a constant speed, so we use a formula, speed is distance divided by time. So speed multiplied by time will be equals to distance. That is for A. What about B? Because B is accelerating, whenever object accelerate, the accelerating object, we cannot use the speed is distance over time. We have to use equations of the motion. So we have to use the equation of the motion here. According to the equation of motion, like because initial velocity is there, 93, and acceleration is there, and we need a distance. So let's say after covering a distance S, the two cars are side by side. Or a distance D is there, the two cars are side by side. So here we'll use the equation of motion. So S is equals to ut plus half a t square, where S is a distance which is travel. U is the initial velocity 93t plus 1 by 2, acceleration is 14, and time is t square. So when you simplify, so the D will be equals to 93t plus 7t square. That is the distance for car B. But what about the distance of the car A? Because this total distance for car A. So the total distance by car A will be equals to what? It will be equals to this 9 plus additional. The distance covered by car A, already it has covered 9 meter, and then plus additional to have to be side by side. So the total distance which this car will cover, because there has to be, yeah. So in that case, the distance which is covered, speed multiplied by time plus time. Why? Because this will give us the distance traveled with the speed of 93 for a time t, and this is already at 9 meter is already covered. So that's why the total distance will be 9 plus speed is 93 into t. Means after time t, the two cars are side by side. But car A first already covered 9 meter, and then additional distance it covered where in a time t, where for a car B it was starting from this point, like this moment, and it is moving at a speed of 93. So this is the for car B and this is for car A. Then we'll just compare because they will cover the same distance. So if they cover the same distance, this will be 9 plus 93t is equals to 93t plus 7t square. 93t we can cancel out. So 9 is equals to 7t square, or we can further simplify this as 9 over 7 is equals to t square, and we take a root both sides. So when we take a root, it will be 1.075 is equals to t. So 1.075, which is approximately equals to 1.1. That is the time interval when the two cars are side by side. Is it clear, this one? The next is at the instant shown, the car A is 100 meter from the finish line. Deduce whether the car A reaches the finish line before B. So to deduce this, what we simply have to do, we have to work out the time, how much time the car A will take to complete the race, and the time taken by car B to complete the race. So first we'll find how much time the car A will take to complete this 100 meters. Because at the instant, we'll find how much time the car A will take. So to know this, we have the speed is distance divided by time. So speed is distance over time. So if we need the time, so time is equals to speed divided by distance. So time is equals to distance divided by speed. Sorry, substitution. So it will be distance divided by speed. So distance it's covered 100 meter and a speed of 93. So 100 divided by 93. So it will take 1.05 seconds to cover this 100 meter. What about car B? At this instant, the car B has to travel 9 plus 100. So the car B has to travel 109 meters. So we'll find how much time the car B will take. So we'll use the formula S is equals to ut plus half a t square. Or you can also use S is final speed is not there. So then quadratic equation it will form. This will be 109. The initial velocity is 93t plus 1 by 2 14 is the acceleration in t square. This will simplify 7. So it will be 109 is equals to 93t plus 7t square. Or when we simplify 7t square plus 93t minus 109 is equals to 0. Use a quadratic equation. X is equals to minus b plus minus under root b square minus 4ac over 2a to get the value for time. So when you simplify, it will give two roots of the time. One will be positive, one will be negative. You take the positive root only, 0.84 seconds. 1 point. So means the car A, it takes less time. Like it took 1.075 seconds to reach this, and the car B is taking 1.084 seconds. So it means the car A will finish the race first ahead of a car B. Is it clear? Because the time taken by car A to reach the finish line is shorter as compared to this time take, or you can have the same time interval and you compare what is the distance covered by car B. Because to complete the race, this can be solved other way around as well. Like how you can solve other way around. After knowing that the car A will take 1.057 seconds to reach the finish line. So you will find how much distance the car B will cover in this time interval. So we'll use a formula S is equals to ut plus half at square. So initial velocity is 93. This is 1.075 plus 1 by 2. Acceleration is 14 and time is 1.075 square. So when you simplify, what is the distance covered by car B in this time interval? This total is 109. To finish the line, it should travel more, equal to or more than 109. But it will come out, I guess, less than 109. So again, the answer will be same, that the car A will finish the race first compared to car B. So 108 meters coming out. So the car B will be somewhat here, 1 meter before the finish line in this time interval. So it means the car A will finish this race first as compared to that of car B. So either you use the time taken by car A to reach the finish line and find the distance covered by car B in this time interval. So it also shows that the car B is not not able to finish the line, as it has to be 109 meter or more. In the question, a lorry is crossing a bridge. The bridge is supported by the two columns as shown. The forces P and Q are acting, as you can see. In part A, when I found that T for a car B, it is 1.13. And T for car A. For part A, show that, no, it should be same time. It should be same time interval. Because we want to show that the car A and B are side by side. If they're side by side, means the distance covered by car A and the distance covered by car B should be same. So the distance covered by car A is 9 plus D, like this. This is D and this is 9. And the distance covered by car A is S. So I should say 9 plus D should be equals to S. So 9 and the distance is the speed into time. So 93 into T. And this is accelerating. So it will be ut plus half at square, 93t plus half, 14t square. Then you'll simplify this equation and find the value for t. And that t should be same for both of them. So it's like the distance, if they're side by side, so the distance covered by car A should be equals to, yeah, 1.13 is fine. 1.13 is approximately 1.1. That's fine.